This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 49. We've been at this for an entire year now, and hopefully next week you'll join us for session number 50. We'll give a quick recap of all of the applications we've covered in the past year. The title of today's presentation is NOAA Flood Detection and Case Study of the 2020 Floods in Manitoba, North Dakota, and Minnesota, presented by Carl Jones, meteorologist and satellite focal point from the Grand Forks, North Dakota Forecast Office, and William Straka, researcher from the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison. Facilitator, we're glad to have Chris Gitro with us today, the MIC at the WFO in Duluth, Minnesota. Just a few reminders before we get started that the session is being recorded and we'll have an opportunity for Q&A after the presentation. Please feel free to put your questions in the chat. Even if you want to ask it verbally, we can unmute you or whatnot if you have a longer form question. We're always looking for future presenters, so if you have an application you'd like to share with researchers and your colleagues in the field, please get in touch with us. We'd love to have you as part of the book club. The training team can help create training materials that may be unavailable or point to ones that you may be unaware of. Brian Mata, the Office of the Chief Learning Officer, can field your questions regarding that. And thank you to OCLO as well as our TowerS team, Krishad Bowman, Lee Byerly, the GOES-R and JPSS programs for everything they do to facilitate the Satellite Book Club. So I'd like to go ahead now and introduce Carl Jones and William Straka. First, Carl Jones, meteorologist with the NWS Grand Forks, received his BS in meteorology from Florida State in 2012, then made the trek northward, creating beaches for blizzards, forecaster for Iteris, providing road weather support for various state departments of transportation, and after 3 years switched over to NWS Grand Forks and primarily remains focused on road weather and satellite applications. And he's joined by William Straka, researcher from UW-Sims now for nearly 15 years, currently focuses on a number of topics, including algorithm integration and the day-night band on VIIRS, as well as for the past several years interacting with stakeholders such as FEMA on utilizing flood and other satellite products for disaster monitoring. I'd also like to note that William has contributed to the Global Flood website training module on Comet, and you'll see the link to that in the chat if you are curious. So without further ado, Carl and William, welcome back to the Satellite Book Club.
Thanks, Jordan. So I'll be starting, and then Carl will join. We'll talk a little bit more about the case study itself. So as Jordan said, my name is William Straka. I'm from Sims. If you go to the next slide. Just a little bit, we're just going to go for a little bit of a background. Then I'm going to give a refresher because I think a lot of us have heard about the LEO flood product from NOAA, and then we'll talk about the case study from the 2020 floods in Manitoba, North Dakota, and Minnesota as well. And then I'll come back and give some information about some other products and a little bit of a summary. The Red River Basin has a long history of flooding with several major events over the last couple hundred years. The last couple of years, well, 2019 and 2020 were relatively mild. It was obviously very extremely dry this year, so there wasn't really any flooding. But basically, it's drained by the Red River of the North, and then proceeds proceeds up northward or southward depending on where you are. So next slide. So just a bit of a refresher on the VIIRS Flood product. It came about in May of 2013 with a ice jam flood up in Galena. It happened to be at a CSPP meeting actually here in the discussion happened at a CSPP meeting here in Madison. But that's where really the idea really came across. And since then, it's sort of evolved into having not just products from VIIRS, but also from ABI and AHI, as well as products that involve both satellites. On a daily basis, for the joint VIIRS ABI products and the VIIRS AHI products, depending on which part of the world you're in, provides the best coverage in the regions covered by the by either satellite. But under clear sky, under clear sky conditions, the VIIRS and the is a visible imager product, which means you have to have clear skies to be able to see the flooding. And the VIIRS product, obviously, with its higher spatial resolution, provides the highest and most accurate flood details. But the ABI and AHI flood maps filter out the clouds through a multi-compositing process. So, at the end of the day, if VIIRS was cloudy, you still get some idea, but it cleared out, you still get some idea from the ABI or AHI flood maps. So next slide. I won't go into too much detail about this, but this is just the list of the products. There are, as you can see, there's more than a half a dozen of the products from the near real-time data, which is either comes from the gravity system or the direct broadcast, and then the daily composites and the 5-day composites, which are of course the maximal extent over the last 5 days, and then, as I mentioned, your individual ABI or AHI flood products, and then the 2 joint products. And those are the approximate times that they're available from each day. So if you go for the next slide. So the VIIRS direct broadcast products are really the quickest way to get the VIIRS flood maps. It's actually going to be the same product once it transitions to the operational system, but it will just be longer latency. Obviously, with direct products, you can get data from Galena up in Alaska, and then over the CONUS, you get the data from SIMS. For the direct broadcast, the latency is about 20 minutes to maybe an hour, depending on where you are and just where you are in displaying AOH2 and pulling it from the FTP server. But we also provide the direct broadcast data both through AOH, but also through GIS tools for display in real Earth and other GIS applications. Obviously, for Alaska, which is currently undergoing breakup, there are many more passes than over the lower latitudes. And then finally, as I mentioned, the VIIRS flood product is actually transitioning into operations as we speak. However, the latency for the granules over the the US and over Alaska from the operational system will actually be 90 to 120 minutes. And this is because the operational system pulls the data from the IDPS, which is where the satellite goes over, and then either every orbit for SUMI and PP or every half orbit for NOAA 20 and 21 and 22 is downlinked, and then you process that half orbit. And then the data, the main point is it's not going to be the data from the direct broadcast, so it won't be as latent as what you see right now if you're currently looking at the products. So next slide. And for here, I'm going to transition over to Carl, who's going to talk about the 2020 Red River Flood.
Yeah, thank you, William. So just a brief background, if you're unfamiliar with the topography and the geography of the Red River Basin up north, it's a valley, so it's very flat, and the majority of the area is composed of agricultural land within the valley, particularly. The Red River itself travels from south to north, and it extends from the majority of the North Dakota and northwestern Minnesota border. Some major metros along the Red River are noted in the map to the right. That's Fargo, Grand Forks, and within Canada, it's Winnipeg. And you can see the topography, and again, just more or less just highlighting that things sort of slowly creep towards the north and captures a rather large area extending into a good portion of eastern North Dakota as well as into northwestern Minnesota. So if you're thinking in terms of water capture within the basin, it has a rather large footprint that it captures the water. Summarizing the snow year that led up to the flood, some of the ingredients that leading up to the flood. In 2019, the end of 2019 was a very wet fall season, and essentially that started off our antecedent condition to freeze those very saturated soils. So going into the winter season, we knew that this potentially could be an issue with any sort of snow melt that we would have gotten from the upcoming winter. Really wasn't going to infiltrate into the soil and was likely just going to go straight into the river and tributaries. And we just so happened to have a rather high snow year that following winter. We had around throughout the winter 48 to even up to 100 inches across the U.S. side of the basin. We even had a top 5 snow year within Grand Forks itself. And within that snow, it led to quite a lot of water content. So basin wide, it was around 1 to 4 inches, and again, highest on that U.S. side of the basin. And then getting into March, we had a rather, or late March, we had a rather quick melt, and we essentially melted the majority of our winter snowpack in around 3 to 7 days, and that's essentially what this map to the right is trying to show, the change of liquid equivalent. As you can see, all that red, all that water melting, and then early April, we had a snowstorm come and deposit around another half an inch to an inch of liquid equivalent, which was subsequently melted quite rapidly after that as well. So a lot of ingredients that led to a rather large flood. And in summation, this is a map to the left, showed our forecast points. As you can see, a lot of those points in red indicate moderate flooding. So we had several of those, particularly in the southern part of the basin, as well as major flooding along the main stem in the central portions from around Grand Forks northward to the Canadian border. Other notables that was kind of interesting is we had an instance of double crest. That first crest indicating that initial snow melt from the winter season, and then that second crest as a result of the April snowstorm water coming through. And that's kind of where those two crests didn't quite phase together. Where they did phase together, it essentially didn't add on top of each other, so to speak, but rather it just created these long duration crests. So as you can see, that bottom right hydrograph at Oslo, they stayed within major flooding for several days as we had that initial flood wave that was a result of the winter snowpack that had melted, sort of phasing with the April snowstorm snowpack that had rapidly melted. In terms of impacts, while it was major flooding across mainly the central and northern portions of the Red River, the main stem Red River, it wasn't close to being record-breaking. So while there were impacts, it wasn't severe impacts, so to speak. And this area up here is particularly well accustomed to large floods, so we have a lot of mitigation ways to mitigate infrastructure in place, and you can see that to the right of that picture of the temporary flood walls. And essentially, because of these mitigation infrastructure, the majority of impacts was largely confined to transportation, and you can see in that middle picture, essentially those blue dots with the red starbursts are points where there was road closures, and you can see there was a really essentially all of the road closures leading from Minnesota into North Dakota or all of the routes were closed that led from Minnesota into North Dakota, Grand Forks to the Minnesota border, or to the Canadian border, excuse me. So getting into the satellite stuff, this is a picture of the GOES 16 ABI flood product. And we used this particular product to get an overall sense of the flood extent to really gauge our overall situational awareness, to get the most up-to-date extent of floodwaters. And it really started to help begin our search to answer, are all of our impacted areas covered by a flood warning? Are we messaging these areas that might be impacted by floodwaters in an appropriate way? And one particular area that caught our interest was this area that's outlined in black. I can go back and you can see that we didn't have any products out for this particular area within Minnesota, Polk County within northwest Minnesota. So this actually kind of helped start our impact assessment. And so zooming in a little bit further, we wanted to confirm if this particular signal from the ABI flood product was valid. So we could use the VIIRS flood product with its higher spatial resolution to help confirm that the signal was valid. And indeed it was valid. And we even were able to see a little bit better detail of where the more higher confidence in widespread flooding was in those darker red shaded areas, mainly to the western part of the black outline. Yeah, and there was a little bit of cloud obscuration towards the eastern part, so it wasn't exactly confident of how far east the floodwaters could extend, and at least in terms of the VIIRS. So that was something maybe we could continue to look into a little bit further. And so with these two flood products, we wanted to continue our search, and can we get even better detail than what VIIRS was showing? And indeed, we got lucky with a Sentinel-1 synthetic aperture radar pass. And this is toggling back and forth from the VIIRS to the Sentinel-1 imagery. You can see that the blue coloring was, indicated floodwaters, and you can see that the floodwaters were mostly confined to the western parts of our area of interest, and that corroborated quite nicely with those red areas that VIIRS was showing. And then even the amount of detail that this type of imagery was showing, we were able to actually pinpoint the specific farmstead locations where we could actually call that property to see if floodwaters were impacting their property. We had pretty high confidence that it was, floodwaters in the agricultural fields, but, getting out of winter time, there was no crops out there, and there's hardly any impact. Just because there's water in the middle of a field doesn't necessarily mean that it's high impacts, but we were particularly interested in those farmstead properties themselves. Switching gears into a little bit of the messaging, we were able to use the flood product ABI imagery within our public facing messaging, and this is that graphic towards the top right. We were able to show that image, and then gave a rather intuitive look of geographically showing where we were trying to highlight where floodwaters were. And then a little bit to the bottom left, we were able to use some of the imagery in a webinar to our partners, and that was mainly all three of the flood product things that we were showing. That would being the ABI, the VIIRS, and the Sentinel-2 and Sentinel-1 imagery. With that, I'll give it back to William.
So yeah, thank you, Carl. So of course, the VIIRS the VIIRS and the LEO Geo flood products are good for knowing where the flooding is occurring. But of course, there are other products that can be related to flooding and ice detection, because the Red River does get ice, as well as many other rivers here, not just in the continental United States, but also in Alaska. For example, the CMORPH 2 precipitation product, we actually did a short course of this 2020, I think it was, in 2021. This particular case, maybe it was a different flood case, but anyway, the idea is it's a accumulated precipitation product that's derived from passive microwave imagers. Of course, in the United States, there's a lot of radar coverage, so it's you got the radar coverage, and you may not necessarily need it, but if the radar goes down, you want to fill the gap in there. And I know people up in Alaska have been evaluating the CMORPH 2 product during their rainy season, which is, I guess, upcoming in the next few months here too. So, but the previous one last year. In addition, there are some up and coming products, experimental products. For example, we're taking the VIIRS LEO product and now downscaling it to the 30-meter resolution. That's to the, Sentinel, the Landsat resolution. And that's currently under development. Is that we're actually running it routinely. We'd hope to look at it this flood season, but no flooding this year with the drought and all. I mentioned ice. I saw KC on here. That the National Weather Center is producing an experimental Sentinel-1 SAR ice detection product, both over the continental United States and Alaska. And they've been gathering a lot of good feedback, and they've done a lot of good analysis over both regions this last winter. And finally, I wanted to touch on, we mentioned SAR for ice detection, but it can also be used for flood detection. And there are actually two projects that are going on. There's a NOAA Flood Supplemental Project, which is to produce a blended LEO Geo SAR product, and one of the candidate pilot regions is actually the Red River from 2020. And also for the CS Disaster Working Group Flood Pilot Project, the Red River is also a candidate pilot project. In that case, we are going to be working with NRCan, which is a partner that many of the northern WFOs work with during flood detection and they using RadarSat. And again, to look at this blending of LEO, GEO, and SAR products into a better product, just like we have a blended LEO, GEO product. So next slide. Yeah, just to summarize, the Red River is an extremely flat and susceptible to flooding, especially during the springtime as the snow melts, if there was any snow this year. In 2020, there was a lot of rapid snow melt, with very high water content, and that was compounded by another snowstorm and melting, and it still resulted in major flooding and impactful flooding, but it wasn't record-setting. It happened to go overflow I-29, which is a major conduit of commerce between the United States and Canada. It was of interest, to not just the Weather Service and the local agencies, but also to FEMA and other national stakeholders as well. And as Carl mentioned, Grand Forks, the WFO up there, utilized the VIIRS and ABI products, along with the ground-based imagery and ground-based imagery from other partners such as NRCan and ESA to get the messaging out there, see where the flooding is, and make appropriate decisions from there. And I mentioned this last time, these international partnerships, the partnerships with the research institutions, and are extremely not just in demonstrating the products, but providing ground truth and verification, as well as the development of the products. So I think that's it. And if you have any questions, there's Carl's and my email. If you have any technical or scientific issues, you contact Jay or Sam May and Donglong. And then, of course, I have to give a shout out to Bill and Mitch and the JPSS program for all their funding and support of these products.
All right, thank you. That was a fantastic presentation. This is Chris Gittro, the MIC up in Duluth, and we'll go right into questions now. But before we do so, just got a couple of announcements that I'd like to make. Everybody who attended, you guys are all welcome to provide feedback on this presentation, and the link will be provided in the chat room for everybody to quickly access. So also for next week, we wanted to make sure that we mentioned that on Thursday, May 20th at 12 p.m., Paul Schlatter, the Science and Operations Officer at the Denver, Boulder, Colorado office, will be giving us a presentation on cirrus geocolor imagery. All attendees are encouraged to further contact the Tower S team of Lee Bairuli and Kashad Bowman for questions about the SBC or for any help that they might need with configuration of satellite products. And more information will follow in an email from the Tower S team at a later date. All attendees who are on the call today are welcome to submit questions in the chat room that we'll be able to ask. And if you'd like to ask a question yourself, just let us know in the chat room and we'll turn it over to you. So without further ado, we'll jump into some questions. So this presentation showed flood detection imagery from 3 platforms, the ABI, VIIRS, and Sentinel-1. Is there any one that stands out on top of the others, or are they all equally beneficial?
Yeah, so I'll go ahead and answer that. So yeah, each platform has its own unique advantages. Using the products with rapidly updating imagery like ABI could be a good starting point to get an idea of where areas that may be affected by flooded waters and closest to real time. You can confirm and refine your geographical location of floodwaters using the higher spatial resolution imagery like that of VIIRS, and attempt to address the question like, are we providing the right service and messaging to those impacted by floodwaters? Finally, further refinement can be made using even higher spatial resolution imagery that's offered from platforms like Sentinel and Landsat. And that was helpful in targeting very specific locations to gauge impacts. And in this case, we use that to really target individual farmsteads to actually call out to and see what impacts might be potentially happening. This type of imagery, however, is only valuable if you're able to get or if you're able to analyze the imagery in a timely manner from a timely pass. So yeah, in summation, all platforms spanning this, the spectrum of resolutions, so to speak, can provide a nice workflow in targeting impact assessments, whether it's the most up-to-date, bigger picture things like assessment using coarser spatial resolution with higher or highest imagery cadence down to very specific location details despite the slower revisit rate.
Okay, excellent. I got a couple of questions with respect to product availability in AWIPS. When will the operational VIIRS products be available in AWIPS, and can you tell us how to access them through the various the satellite menu that we do have in AWIPS?
Okay, so for right now, well, I know that Lee and John Evans are busy working on, there's some formatting issues that they're working on for the operational feed, and at some point there's going to be a decision on how it goes over the network. So I don't have a date on that just yet, but you can get the VIIRS and ABI products, not the joint products, but the 2 products themselves separately from the SIMS LDM, and I will post a link to in the chat to a Google Doc that has instructions on how to do that, as well as a link to the NOAA the NOAA Satellite Proving Ground Flood website as well, which has some documentation on the product. There's a little bit of a quick guide there and the like for that. And of course, if you have any questions, do feel free to email me with that, any questions. I'm on vacation next week, but I will answer emails as quickly as I can.
All right, fantastic. You guys showed an example of using the VIIRS ABI flood product in a graphic generated for public consumption. Could you elaborate on how you're able to do that? Carl, I think you might be muted there.
Sorry about that. Yeah, so this particular graphic to the top right, I think is the one referring to that we use the VIIRS and ABI imagery in our public-facing graphic. We were able to adjust the flood product scheme within NWS by setting a value lower than around 60% transparent. That was kind of arbitrarily chosen, I guess, so to speak. We really wanted to just show the more confident areas of widespread flooding. And then we displayed a plain colored background using other GIS and shape files underlaid. We also wanted to make our own color bar legend linking the warmest colors to floodwater coverage, and such as local to widespread. This made for, again, that intuitive map by locating areas experiencing widespread flooding, and enhance the contrast between higher confidence floodwaters to areas that we're likely not experiencing as widespread a floodwater. And then we also coupled the map with an aerial photo that we received of that particular area from an airplane, which we thought gave some life to the imagery, as well as provided some scope of the aerial extent of floodwater. And essentially these two particular images we thought were pretty attention grabbing, and essentially was a way that we could really promote our safety messaging across, and that being those bullets to the bottom right, such as heeding instructions from authorities and don't drive through floodwaters.
Excellent. Yep, for sure. Bill would like to know, do you have any, did you guys have any dealings with the Canadians during this event? And how did you communicate with the Canadians during other events such as this?
Yeah, so essentially, at least from the NWS Grand Forks side, most of our Canadian partners sat in on the webinars that we provided. I can't exactly remember how often we had the webinars. If it wasn't daily, it was at least once a week. But that was the main link, to my knowledge at least, how we were able to get our communication across to Canadian partners. As far as satellite imagery, we were actually in contact with one of the Canadian institutes, and they were providing some of their synthetic radar imaging, something similar to the Sentinel-1, but from one of their own platforms, and we were being given that type of imagery for operational use, which was pretty helpful. We used it more or less in the same way of trying to assess areas of impact, and if our messaging kind of essentially covers areas where we were thinking floodwaters were happening.
Okay, great. I'm just going to ask Bill, the links that you provided, did they contain Sentinel-1 SAR flood imagery, that information? Jarrell was asking.
Oh, you're talking to me, William? No, it doesn't. I don't know where I have them. I have the S1 data set somewhere. I have to look for it. But I think, Carl, you had mentioned where it was in your slides, so I can take a quick look for it.
Yeah, essentially we were using it's this particular imagery that referring to. This imagery was used using the Sentinel Hub website, and it's pretty easy to just do a quick Google search of the custom scripts that you can just copy and paste into the actual Sentinel Hub website. In this particular case, it was I forget exactly what it was called, but it was already a pre-made composite that was meant to highlight floodwaters. into that particular website platform, the Sentinel Hub.
And I just put the Sentinel Hub website into the link into the chat.
All right, thanks, William. Let's see here. I'm not seeing any additional questions at this time, so I think I'll go ahead and turn it back over to Jordan.
Thank you so much, Chris. And thank you once again to our presenters today, Carl and William. Great presentation, very insightful. And thanks to all of you. We got almost 100 participants today, so that's just fantastic. As a reminder, I hope you'll join us next week, Satellite Book Club Seminar Series, session number 50 with Paul Schlatter. Sue at the Denver office is going to be discussing geocolor imagery. And in the meantime, if you have any questions related to satellite data in your AWIPS, we've got John Evans, Lee Byerly, and Kishad Bowman who can help you out. Send them an email or find them in the NWS chat. So with that, I hope everybody's spring is off to a great start, heading towards summer. Stay well and hope to see you next week. Take care, everybody.